Hello, viewers, listeners from wherever you're tuning in from around the world. Welcome to another episode of the Amazing Podcast. We're so happy to bring this to you every week almost now. And we're talking to some really cool startups in the space. And we're talking about different things related to cloud computing. And most of our episodes, if you've been following, have been centered around kind of Kubernetes, cloud native, that space. Today, we're kind of going off to a little bit away from that. And we're going to talk about something that is kind of related, but not fully in the Kubernetes space. My name is Twain Taylor. I'm the editor at amazic.com. And I have with me Kacper Łukawski, who is the developer advocate at Qdrant. So Qdrant is a startup in the vector search engine space. And this is a new form of a database. And Kacper will be telling us more about it. So we're going off to a little bit of a tangent today from what we usually talk about. And we're going to talk about databases, so data. So if you work with data, especially large, complex data sets, then you want to be listening in today because Kacper is going to be sharing to us about what's really happening in data analytics, what's cool, what's new, and Qdrant's approach to data processing and analysis. So with that introduction, I want to welcome Kacper to the show. Kacper, thanks for joining us. It's wonderful to have you with us. How are you doing today?
Hello, Twain. Yeah, thank you very much for the invitation. I'm doing great. Hope we are going to have a great discussion about vector search because I'm really excited about that technology.
Yeah, absolutely. It's very new, and I'm sure even for a lot of our listeners, it's a completely new topic. So, we're really looking forward to what you have to say. But before we get to that, can you tell us a bit about yourself, Kacper, your journey thus far up to Qdrant? What have you been up to? What's your background?
Sure, yeah. So in 2010, I started my computer science studies in Krakow, where I'm based. And actually, at the same year, I also started working as a freelance software developer. At this point of time, I was mostly implementing some simple websites, but I was really into that. So that was like the start of my journey as a professional developer. But then I joined some different companies. I was working as a software developer, then switched to some big data processing. I'm not sure if big data is still being used, but basically I was doing a lot of things with Kafka and Apache Spark, and also started looking at machine learning because I got excited about all those topics. I also had some machine learning classes during my studies, and that was always amazing for me to see how machines can work on their own and make some conclusions out of the data. So that was like a natural switch. I also started doing some consultancies for those companies who wanted to implement any sort of machine learning applications. And then the whole buzz around deep learning started. And as a natural process, I joined Qdrant because they are doing something in that space, because vector search is also about some deep learning neural networks. And I was also amazed how easy it might be to solve these vector search problems that I thought are not that easy to be solved before. So that's the whole story. I'm already on board for around a year. I joined in May 2022. So yeah, it's been a year, and I'm still really happy to be a part of that team.
Awesome. Yeah, sounds like you've really you played different roles in your journey, working with data as hands-on a developer, and also consulting and sort of thinking of solutions around data. So I think you'd be a great person to tell us, as we start, if you can trace kind of the history of databases leading up to vector databases, graph databases. Where does this come from, and give us some of the history.
Yeah, basically, so when it comes to any sort of databases, I believe that everybody should be pretty familiar with SQL databases because we are just used to using them quite heavily in every single applications that I actually implemented. So this is one of the ways of how we persist the data for the purposes of our systems. But that's just one of the paradigms. We have NoSQL like databases, MongoDB, and things like that, column-oriented databases, and a lot of other approaches of how to store different kinds of data. And for the purposes of vector search, we need not only a way how to persist huge numbers of vectors in on a cluster of machines, but also another way of how to extract some closest entries in that space. I really love that example. I would compare those vectors that we store to some sort of geo-coordinates. If we speak about the globe, we can encode every single position on the globe using just two-dimensional space. There is a geographical latitude and longitude. But in case of vector search, we are typically dealing with vectors with hundreds or thousands different dimensions. And that becomes really a challenge to find the closest points in that space. And the easiest approach you can imagine, like going through all the points we have collected, doesn't scale at all. We need a better way of how to find those nearest neighbors, because that's how we call that. And that's what we need vector databases for. They not only encode our data and store them on disk, but they also perform this approximate nearest neighbor search that really speeds things up. And that's like a game changer, because we've been dealing with this kind of data and couldn't scale it up. And vector databases changed that market a lot. Nowadays, everybody can just use them as a tool, but before, people were just re-implementing that stuff over and over again. And none of those existing approaches, existing paradigms like relational databases cannot really solve that easily. That's a completely different use case. We need a different tool to have the best algorithm, the best way for our relational data, and a separate one for vector search.
Okay. So next I want to ask about like a definition of vector search. But before that, I just want to probe a little bit more into this that you said that the traditional databases don't scale when you have more than 2 or 3 dimensions in your data. So I'd like to just get some more information, so in what way do they not scale, and how are they designed that makes them incompatible for something with a data set with 100 dimensions, for example?
Sure. Maybe I didn't mean that these traditional databases that do not scale, but in traditional databases, we typically store some attributes which are related to each other in some way. Let's say we store some information about people. So people in any system would probably have like their first and last name, maybe an email address, birth date, and all those attributes which are describing a single person. But those attributes are not really like combined to each other. We can look at a single column and let's say derive some statistics out of those single columns only. And if we create a relational database, relational tables in that database, we typically create some indexes on those fields that are quite often being filtered by. So if we want to perform a quick lookup based on the age of people stored in that table, we would probably create an index on the column with their birth date. And that would be like the optimization to be done. But if we talk about vector search, we have like a numerical vector with, let's say, 500 different numbers. And those numbers do not have any sort of meaning that we could derive from the perspective of a human. they just look quite randomly. We have like 500 different numbers stored in a vector, and we cannot really say which of those numbers are really important. In reality, all of them are quite important for us, because we are not looking at the attributes of the data, but just encoding the original data into a different representation. And this representation is completely non-readable by human. It is only usable for those deep neural models. And we need a different approach to find data. We no longer need to filter by a single attribute, but we need to calculate the distance to all the points that we have stored. Let's say, maybe I will just provide you an example. Let's say you would like to find some images. There are already tools like Google Lens that you can use to find some similar items based on the photo you provide. And it cannot be done like pixel-wise. We cannot compare pixel to pixel and find some similar examples, but we need to derive some kind of semantics of the picture we are using to search with. And this is what those neural representations created by deep learning models are great for, because they can take those original images and create a different data representation that will be encoding the semantics of the input. And so let's say if we have two different pictures presenting a dog, the system, this neural model will create a similar vector representation. It won't be the same representation for two different pictures. It might be even a different angle, the same dog, but different angle. And the representation will be not identical for both examples, but pretty close to each other. And the whole goal of vector search is to find those closest points in that space. So we can then say, like, for this query, I found those documents to be the most relevant, to be the most similar to the provided query. And we can use that approach to solve multiple different problems. It turns out to be quite universal tool. So this is just not the use case those traditional relational databases were designed for. Under the hood, those SQL-like databases would typically use B-tree-like structures to encode their indexes, but none of those data structures that they typically use do not solve the problem of the similarity search in high-dimensional vector space.
Okay, got it. You can correct me, but I'm trying to kind of get an example to understand this better, and you can correct me if my example is off. But I'm thinking of like an Excel sheet or Google Sheets spreadsheet, with its rows and columns of data all related to each other in a very organized way, and that's like your traditional relational database. And then you have the more complex thing that I'm thinking of is like a Google search engine or its crawlers, where it's crawling web pages and it's trying to find relevances, what matters there, right? You're trying to find for each keyword which is the most relevant page, and then Google ranks them 1 to hundreds, the most relevant pages for that query. So it's not a one-to-one correlation, but it's more about which is more relevant than the others. And so it's a different way of thinking about this whole thing. Is that a good example, would you say?
Yeah, that's a good example. Actually, you described the process of keyword-based search. So that's a different approach, and that was quite popular. It still is. And there are tools like Elasticsearch, for example, or OpenSearch. But those are probably the most popular tools used to perform this keyword-based search. And they really rely on the keywords under the hood, and that's an issue as well. Actually, I wanted to bring that topic to the table later on, but that's really cool that you mentioned that, because basically this is somehow similar to what vector databases or similarity search may provide you as well. But the first problem with keyword-based search is that you need a lot of heuristics in order to configure it properly. Let's say you have a bunch of documents. That might be also some sort of crawler like the one used by Google. and that just it just indexes the websites that it visits. So that's a simple process, and then you can use those indexed documents in order to perform the search process. So you have a query, and somebody wants to find the most relevant pieces. And this is fine, but as long as you know the exact terminology that is going to be used on those websites. Let's say if you are looking for a specific book you want to buy, and you know the title of that book, then this is pretty easy. You can provide the title, and that should be already able to find the best results. But if you do not know the exact terms that were used on within those documents, then things are getting a bit more complicated, because you need to experiment several times with your query, or somebody else needs to configure this keyword-based search system in a way that it will be converting your query to some synonyms. In some way, it will be just unifying the language that is being used in queries and documents in order to find those relevant examples. And this is fine. That might be done. There are also some huge search teams within bigger organizations that are trying to configure those tools in a way that it will be providing the best results possible. With vector search, we are actually able to solve that problems of synonyms, but also problems related to multilingual search as well. And there are things that cannot be simply achieved with keyword-based search, or at least cannot be achieved that easily. I should also mention another thing, because there are like two things related to vector search, two components that we need to have. And the first one is a neural network that will be taking the original data and providing the vector representation of that piece of data. The data might be anything you can think of. It might be textual data, and that's probably the most common case, but those might be images, videos, audio signals, time series, or any other data that you can imagine. In medical processing, they probably use a different sort of neural networks, because they have some videos, but also some additional data. But it doesn't really matter what you choose, because you will always receive a fixed dimensional vector with, let's say, 500 numbers in it, no matter what you put as an input. And that's cool, because you can normalize your data and then perform this vector search. And that's another component. The first piece was this neural network that you need to provide, that will be converting your data into vectors. And another thing is this vector database, similarity search engine that will be providing you with the most relevant examples based on some sort of distance between the points. So yeah, exactly. Your example was completely fine, and that was like an approach that is that might be achieved with keyword-based search as well. But vector search is slightly different because it doesn't require textual data, but it might be literally anything you can imagine.
Wow. Okay. Yeah. Sounds like it's kind of like the building blocks of, AI, and everyone's talking about AI right now, but sounds like, underneath AI, this is the stuff that really happens. Would you say that?
Yeah, actually, I'm also happy to talk about that story, because I'm not sure if you are using ChatGPT, but everybody does. So I would expect you to use it quite often.
Yeah, it's fun.
I use it too. It's really cool, but the problem that I had with this original ChatGPT that was released in November, yeah, I think so, was that it could provide you with some text generated based on your prompt, but it wasn't really taking into consideration some latest news or some private data that you could possess, and you could you would want this model to use in order to provide you with this texts. And that was a huge issue. And OpenAI started implementing something that is called ChatGPT plugins. And we at Qdrant were also working on that. So right now you can create your own plugin or use some already existing ones in order to bring your own knowledge base into those ChatGPT models. So yeah, this is one of the building blocks of those modern large language models, and that we are really excited about being a part of that.
Wow, really cool. I wanted to ask about the definition of vector search, and if you could kind of give us a definition that's in simple words and easier to understand for those who are not familiar with vector search already.
Okay, sure. So in a nutshell, vector search is a mechanism of finding the most similar examples based on some neural embeddings, neural vector representations. And I should probably elaborate a bit about those neural embeddings. So basically, every single neural network you can imagine uses some sort of numbers. A typical neural network is built from layers. So at each layer, we have some sort of weights, and we just perform some nonlinear transformations of the input and produce some sort of output. But if we look at a specific layer, let's say we put some data as an input, and then it is just being processed over those layers from bottom to top. And at every single layer, we have some sort of temporal state of that network. And it is some sort of vector, some sort of numerical representation. And it turns out this numerical representation is able to encode some useful signals from the original data. So this is just a different data representation. And that turned out to be quite useful if we do not focus on those individual numbers, but we focus on the distances between different representations. So an example I already mentioned, so two different pictures of the same dog, but taken in different lighting conditions or from a different angle, should have a similar representation, even though their pixel representation is completely different. The colors are different, and the image size might be completely different between each other. So, long story short, neural or vector search relies on distance between this neural representation, different in this distance in some high-dimensional vector spaces. Because this distance might be pretty useful to determine some similarities between the objects.
All right. So yeah, that's pretty good. Thanks so much for that. And I wanted to get a bit more into, we talked a lot about the landscape, data analysis, the problems it solves in general. I want to get a bit more specific and talk about, organizations and teams that are working with data and are listening to this. They're probably doing things a certain way since a while, and they feel like, yeah, it's not the best, but then it gets by maybe. I want to ask about what are some of the pain points or some of the warning signs that, these organizations and teams that work with data should pay attention to, which tells them, hey, you guys are using the wrong database for this data. You should consider using a vector database. What are some of those signs that people should look out for?
Yeah, so definitely I would mention the search team. In any organization that needs to have a search engine over their internal data, there has to be some sort of search engine under the hood, and many people working on configuring the search system, bringing the data in. And if you are fine with your search engine, then you don't really need a vector database, I would say. But if you want to, let's say, perform your queries not only using textual in a textual way, but let's say you would like to perform the reverse image lookup. So you would like to upload an image and perform the search using the image directly without providing some sort of OCR. Or if you would like to perform textual search, but you are struggling with different terminology being used in the documents you have and in the queries, or if there are multiple languages you would like to support at the same time. Let's say I have a bunch of documents which are written in German, but I would like to query them using English queries as well. So those issues are not easily solvable with keyword-based search. So search department is one of the teams that should consider having a look at vector databases, that's for sure. But also all the data scientists should already know vector search. Actually, not sure how our audience is familiar with machine learning algorithms, but there is one of the first algorithms that is typically being taught at universities is k-nearest neighbors, which actually is quite powerful but doesn't scale well. And vector search and all the vector databases are actually doing basically the same thing. We are doing KNN, but in a different way, in a way that is scalable enough to be used in production-like systems. So similarity or vector search might be also used in cases when you are trying to solve things like classification or regression as well. But classification is probably even more exciting, just because in traditional systems, if you solve classification problems, you have a bunch of classes that is predefined before you even start training your neural network, let's say, or a different system. I don't know, it might be XGBoost or some sort of other tree-based systems, but doesn't really matter. But this set of categories, set of labels is provided to you beforehand, and that cannot change when you already started using the system. And this is the problem that is easily solvable with similarity search. Because here we do not assume anything about the classes we are going to detect, but we are just providing a huge data set of some examples that we know, and we can label them on our own. But those labels may change over time. Let's say you want to create a simple system that will be distinguishing different car brands, different car manufacturers. That's fine. You could possibly have a data set of some images. You could train your network, but then there is a new manufacturer on the market and you need to provide some new examples to your system, retrain the network over and over and again once there is a new category you want to include. With vector search, things are way easier because the process doesn't change at all. You will be encoding your images in exactly the same manner, like you did before, but the labels that you are attaching to your examples from the database might be changing over time. And then the process goes as following: you encode the data, you extract, let's say, 100 of the most similar examples from your database, and you do a simple voting. So that might be also solving classification problems, also in case of some extreme classification when you have hundreds or thousands of labels. That doesn't, it's not that easy to be solved with traditional neural networks. It's pretty easy to be solved with vector search. And the cool thing about that is also that you don't need to train your networks on your own. You can take some pre-trained models. There are plenty of them available for free. For example, in Hugging Face Hub, but also those are being published by different players like Google, Facebook, and all those big companies are publishing their models quite often. And those might be used directly without any fine-tuning. So data scientists or people working in data analysis may start using those methods without training the models, which is kind of interesting. But still, if you just want to experiment quickly, you can take an existing model, give it a try. If that works for you, then you have a working product done within a few hours, not weeks and not days even. But there are also some other cases like anomaly detection, because those neural embeddings might be also used because under the hood, we are calculating the distance between the points. And this distance is might be measured. That is just being returned along with the closest points. So once we receive a point a query that is really far away from the others, then it might be thought as some sort of anomaly. But there are some more fancy methods that might be applied here. But this is also another thing that might be solved with vector search, and that's what also why I was so excited. I'm still excited about vector search, because it's so widely applicable to different problems. Then it's probably one of the most universal methods available right now on the market.
Awesome. Yeah. Thanks for that detailed response. And I want to ask, shifting gears now to Qdrant itself, and if you can tell us a bit about Qdrant's approach to this whole vector search, and data analysis. Yeah, give us a bit about that. Tell us about Qdrant.
Yeah, of course. So Qdrant is one of the vector databases available in the market. It all started like 2 years ago, where our co-founders were dealing with some problems that should be solved with similarity search, but there was no tool that was fulfilling their needs on the market. At least there was no open source tool available, but I believe there wasn't any. Because Qdrant is one of the possible choices here, but we are really focusing on the performance. And there's also another thing that you need to consider while doing vector search, because vector search is not all you typically need. Let me maybe just explain that using this example. Let's say you have an e-commerce store and you are selling clothes. So whenever I go to your website and I would like to buy, let's say, a new shirt, then I also have some additional criteria. I can provide you with a photo of a shirt I would like to buy or a similar one. But I also have some additional criteria to be applied on top of that. Let's say I want a specific size, maybe the same shape but a different color, or a different pattern, and all the criteria you can imagine regarding to clothes. And those are not easily encoded into vectors. I mean, those information are encoded into those neural embeddings, but we cannot like subtract them easily. Let's say I have a different vector representation for striped shirt, and I will just subtract from my original query, and that's it. That doesn't work that easily. We have vector search mechanism included in Qdrant, but there is also an extensive filtering. We have extensive filtering capabilities included as well. So we can provide your vector representation and put some additional criteria. So I want a similar piece of cloth, but a different color, a different manufacturer, or a different fabric, no matter what I select. And the problem with the other vector databases is that they either use pre-filtering or post-filtering, and both methods have some disadvantages. Let's say with pre-filtering, let's say I'm running an e-commerce with, I don't know, 1 million shirts, but 90% of them are made from cotton. And somebody just want to find a different fabric, but well, actually, I want to find a shirt that is made from cotton. So I applied this filtering criteria as well, together with my image that I used to make that query. And then like 90% of the items in my stock fulfill those criteria. So with pre-filtering, I would need to get through all the possible results and store some sort of list of identifiers matching my criteria. And that doesn't scale at all, because I would have almost 1 million IDs stored for every single query that's including this sort of filters. Of course, there might be some heuristics applied on top of that, but pre-filtering might end up with full scan. And we all know that doesn't end well if we perform full table scans every single time we receive any sort of query. At least that was an issue with relational databases. But there is also a post-filtering approach. So let's say I want to find top 10 results. So I want to find top 10 results, but there are some additional filtering criteria. So I would extract, let's say, 100, and then apply some those additional filters on top of that. And that might be working quite well in the example that I described, because possibly all the results, all the relevant results extracted during the vector search phase will be already made from Cotton. But in the worst case scenario, I may end up with having 100 of candidates and none of them will be matching my additional criteria. And that's an issue with post-filtering. And those two approaches are implemented with some other vector libraries or vector databases available in the market. But we have quite a unique approach to apply those filters directly during the vector search phase. There is an algorithm which is quite popular. Everybody uses the same algorithm. There are just some differences in the implementation itself. It is called HNSW, that stands for Hierarchical Navigable Small Words, and that allows to find those similar examples using some sort of graph-like structure. I'm not going to go into the details that much, but we have incorporated this metadata filtering directly into the vector search phase, and that makes us really unique. And we are Rust-based, and that makes us also quite performant. Because one of the concerns that we had was that people should have a tool that will allow them to perform the similarity search, not using some huge setups consisting of, I don't know, hundreds of machines running only to support similarity search in the system. But that should be affordable, even at million scale, should be feasible to everybody, to every single company that could benefit from that. So we are focusing on those aspects of similarity search.
All right, great. And so I was wondering if you could show us what's it like, to be working with Qdrant. If you could show us some sort of demo or example of the product itself. Do you have something like that?
Yeah, I think we could talk about one of our users that is doing. They have their own product, which is also open source, available on GitHub, and that might be interesting for our listeners. That's basically a code search platform, and we actually are all used to code search. If you use GitHub, you are probably looking for some code snippets that might be relevant to a problem you are trying to solve. Let me just share my screen. Maybe that might be the easiest way.
Yeah.
Because I would like to introduce you to Bloop, and Bloop is a platform that allows you to perform the code search. So you can provide some queries, but under the hood, it doesn't rely on the code itself, but it also performs the similarity search using Qdrant. So you don't really need to know a specific phrase that was used, let's say a variable name that was used in your code, or a specific terminology that was used, the name of the function, but you can provide a natural language query, and it will be providing you some relevant results based on that query. And there are some cool examples, like how can I get a quick relational data store? And it just automatically indexes your code base and provides you with this similarity search, semantic search capabilities over your code base. So this is pretty cool. There are also some additional functionalities. But the thing is that with similarity search done with Qdrant, you can set it up quite easily, because you don't really need to wonder how to solve this semantic search at scale. I really encourage you to have a look at their website. We were also doing some own demos in terms of code search. We have tested things out, and it seems like there are some promising ways of how to handle that. And that's also one of the building blocks of any sort of Copilot-like tools that allows you to cooperate on code with some AI models. So we are pretty excited, because this is also important to extract the relevant pieces of code depending on what you want to provide. So Bloop is one of the tools that we are really proud of. But if you would like to see some more examples, we have, actually already finished that, but the hackathon that we organized together with Cohere, the winners are already announced, and there are a lot of cool ideas of how to use multilingual semantic search. I may just mention the winners. There is AI Brand Intel. This is a project that won our hackathon, and this is the tool that allows you to perform brand monitoring using multilingual semantic search. And they used Qdrant as one of the building blocks. Again, Qdrant allows to find not only the occurrences of your brand name in social channels, but it also allows you to find some relevant discussions, relevant posts in different channels. So you are always sure that you are up to date with your customers. You can track their the occurrences of your brands, the perceptions, or the perception of your brand, and all the related discussions around your specific area, your specific domain. So this is really cool, but there are also some other tools like multilingual semantic search for e-commerce. So you can use natural language queries in your language and try to find some items in a store that is using a completely different language. So this is also cool for immigrants, and a lot of more cool examples. So there is a hackathon website at which we announce the winners. So really encourage you to have a closer look. But we have plenty of satisfied customers using our vector database on their daily basis, and they're pretty excited. I also invite you to join our Discord community, because people are quite active here. So you can also see what the other are working on.
What's the website for this hackathon? Where can we find that?
It was conducted together with LabLab. I think we can put a link to the description if you don't mind. I may send you a link directly to the website with the announcement of the winner. Sure. That might be the easiest way, because the link is pretty long. Okay, sure, yeah.
But yeah, Bloop looks pretty cool, and it's a chat interface. It uses natural language. Kind of reminds me of just the ChatGPT experience, and I think ChatGPT has had such a broad cultural influence now that I think there's going to be that wave of ChatGPT like user interfaces, and Bloop seems like one of them as well. But seems like what Qdrant does is it enables any anyone who has a tool or a product they're building and they want something like a ChatGPT for their product, something smarter and better. They can use Qdrant to integrate that and bring that functionality into their product. Is that true?
Yeah, it is to some extent. Yeah, but if you already use ChatGPT, you can use Qdrant in order to provide your knowledge base. So ChatGPT is then going to use your data and generate its responses based on your documents. So this is pretty cool. This is something that you can do, but I wouldn't say that Qdrant is like one-to-one replacement for ChatGPT. We are just providing a piece that might be important to be included, because I may just elaborate a bit on how Qdrant got integrated with ChatGPT through plugins. So basically that has been announced like almost a month ago, I believe, but at least a couple of weeks. And actually the problem with ChatGPT was that it wasn't incorporating the latest news or some internal documents. Actually, it couldn't integrate those private data sources because they were not exposed to public. That's obvious. But since they introduced this mechanism of plugins, ChatGPT is now able to determine that to answer a specific question, it should connect to a specific plugin, and it asks the question in a natural language. So it just extracts pieces of the prompt, or just rephrase that prompt in order to provide a query. And this query is sent to the plugin. And the plugin might be any system you can imagine, as long as it provides a specific interface. And we provided Qdrant integration. There is also a tutorial on our website that you can freely use to create your own plugin. So then you will be using Qdrant as some sort of knowledge base, and you will be putting some data into your knowledge base, and that will be automatically available to be used by ChatGPT. So whenever you ask a query, let's say you have your company's knowledge base and you ask ChatGPT to provide you some answers related to your company. I don't know, you put a company name or just provide a prompt in a way that for a human, that would be easy to understand that there is a need to have a look at your knowledge base. ChatGPT will be doing exactly the same thing. It will be asking the question to the knowledge base, and this knowledge base is going to provide you with some answers, with some documents that might be relevant. And those documents will be then reused by ChatGPT in order to summarize them somehow, extract the meaningful pieces, and provide you with the concrete response. So this is how it's going to be working. But Qdrant itself doesn't have anything related to text generation. It rather acts as a search engine.
Okay, interesting. And these plugins are part of the Qdrant product, right?
We have open sourced. Actually, this is a repository of OpenAI, but we have contributed to this repository. There is a ChatGPT retrieval plugin available on GitHub that you can use as some sort of framework. And then we have that description on our website, how to use that plugin in order to create your own plugin that you will integrate with ChatGPT. It's not like included in the core Qdrant. We are just purely focusing on the vector database, but all those integrations are just coming as some separate projects. And the same is for this particular one. So this is like a separate project that you can freely use, but it's also open source, so it's available for everybody.
Oh, that's great. And I want to ask about just privacy and those concerns around this, because ChatGPT itself says, don't give me any of your private data, and it's AI. So, with connecting it with a plugin, how do we ensure that that privacy is not compromised? Any thoughts on that?
Yeah, you are actually the one responsible for that. You shouldn't be bringing your private data into those plugins as well. But let's say you have a company and you have a lot of documents which are available to public. I don't know, you are a bank and you have a lot of PDFs on your websites that everybody should have a look at before signing the contract, but nobody does. But if I wanted to search for a specific piece of those documents that might be relevant in my case, I don't know, I want to make a complaint and I want to find the form that should be used to make that complaint, I would be either checking all the documents on my own, or I can also ask that question to ChatGPT. But of course, you shouldn't be using your private data and putting that into this knowledge base. But there are also some other ways, because there are also some other models. I'm thinking about Alpaca that you can run on premise. There are some open source models as well that might be used, and I also know that some people started working on bringing those plugins into those on-premise models as well. So I believe that within a few weeks or months we are going to have a complementary system similar to ChatGPT, but this time you should be also able to run it on your private data, because there won't be any risk that it will be exposed to anybody else. But right now, that you are absolutely right. You shouldn't be bringing private data of ourselves or the companies that we work for to ChatGPT plugins. That's definitely too early stage.
Interesting. Yeah, so we're almost out of time. And it was a wonderful conversation. So, for someone who is listening to this and excited about Qdrant and they want to get started, I want to get a taste of Qdrant, where do they go? How do they start?
So basically, our Discord community, if we can put a link, that would be really great, because this is the place where we are trying to support our community in setting things up. But I would also encourage you to have a look at our website. We have some articles describing how to use Qdrant in different cases. If you have a specific use case, I'm also happy to provide you with an additional tutorial, because we are really working hard to extend our knowledge base, the tutorials page and articles page, with some new examples. And I would really love to know what might be interesting for you. So our website, our Discord community, we have a bunch of articles of how to get started. We are also trying to describe the concept of vector search, because that might be not that natural comparing to, let's say, relational databases or any different databases we use so far. So there are plenty of concepts, but the good point is that you don't really need to know much about data science or machine learning or any sort of neural models, because there are plenty of tools that are available as SaaS solutions. So you can basically take an API, integrate that with your data and with Qdrant, and you can perform the similarity search using Cohere or OpenAI or alpha embeddings. So you don't really need to focus much about training your networks. You can take some existing ones and start doing that right away. And this hackathon I already mentioned, that's also a good place to be inspired. And in the future, we are also going to extend our presence on YouTube. So I really encourage you to subscribe to our channel and look for some new tutorials, because we'll be publishing some videos with some tutorials describing of how to get started with Qdrant and with overall with that vector search in minutes or hours. So hopefully that will be like a inspirational content for everybody who hasn't really heard much about vector search yet.
Awesome. And your website URL is? The Qdrant website.
Yeah, the Qdrant website, you can find some articles on Qdrant's website.
It's spelled differently, right? It's not Quadrant.
No, it's Qdrant.tech.
Okay. So
if we could
Qdrant.
Exactly. If we could put a link to the description, it would be also cool. But yeah, that might be confusing. That's spelled differently, and I know that people may have some issues with providing a proper address. So yeah, thanks for addressing that.
Yeah. All right. So everyone, if you're listening and you work with data that is that's not the usual text and numerical data, and you're looking for ways to get more value out of your data that's unstructured, things like images, audio files, video, all of that, definitely take a look at Qdrant. And if you're looking to find things like similarity search, and if you want to bring in some AI use cases, leverage even ChatGPT using plugins, Qdrant seems to have some really cool solutions for all of those use cases. So go to their website, qdrant.tech, check out Qdrant, and see if you can do something cool with it. So with that, we come to the end of the questions about the product and the industry. I want to get to know you questions, Kacper. What would be your alternate career path if not for your job in tech?
I haven't really think about that much, but basically, yeah. Also, I always wanted to be an actor. I didn't have that chance, but probably I won't have. Well, but if at any point anybody could invite me to take part in theater, I would be really happy to just jump right into that, because that would be like I think that would be like a perfect match. But yeah, I didn't have that chance, so well, I wouldn't say that, unfortunately, but that's why I started my tech career instead.
Wow, really cool. That's nice. It's a very rare one, theater. I also saw on your LinkedIn that you founded an NGO called AI Embassy, is it?
Yeah, that's completely right. Yeah, that's another thing I'm also working on. This is a non-profit organization, and we are trying to talk about AI. We are mostly operating locally in Poland, where I am based, but we are also trying to go and extend to whole Europe. But basically, that is a non-profit organization which is purely focused on spreading the knowledge about AI. We are trying to be visible on different events, not only the technical ones, but also we are targeting those people who might be sort of digitally excluded and who might be excluded from all the benefits that AI may bring to us. We want them to understand what are the pros, cons, and risks, and want them to be prepared to the revolution that is actually happening already.
Wow, really cool. And who's already part of this, and who do you think this is a good fit for if someone's interested in something like this?
Well, basically everybody who would like to, who understands artificial intelligence a bit and would like to spread their knowledge. We are really open to anybody. We are also trying to build some sort of team of volunteers that will be working together on solving some social issues using AI. We just simply believe that that's a piece of technology that may change the lives of people affected by different conditions. We want to perform some volunteer work together to just help them. And there are organizations that are really inspiring for us, things like Omdena, which is also a non-profit organization working on some social challenges and trying to solve them using data science in general. We are basically trying to do the same thing. So everybody who is interested in using their knowledge is really welcome.
Cool. How can someone get involved?
Please just feel free to reach using our LinkedIn, or just go to our website, which is embassy.ai, and there should be a contact form. You can just send us an email. We'll be preparing something for the autumn. Hopefully that will be this will be announced properly and bring some attraction to what we do.
Okay, cool. All the best with that.
Thank you.
What was the moment that you knew you were going to be a developer?
Well, it all started when I was in my primary school, I believe.
Whoa.
I was playing some video games, but they used to be quite expensive. I'm not really into video games now, so I'm not really sure if they are more or less expensive. But they were definitely too expensive, so I decided I would write my own game. I would create my own game just to avoid paying for those expensive ones. And I started doing some programming classes. At this point of time, there were some books that I read about C++, and I didn't understand even a single piece out of that. But I also started doing some simple websites, and that just got me excited. That was actually the only industry in which you don't really need to have like a huge power supply, huge know-how, but you can start doing things quite easily, and you see the results of your work within a few hours. So this is really exciting about programming and development, and that's how it started. I was like 14 at that point, I believe.
Wow, really cool, really cool. What's one work tool that you can't live without?
Well, nowadays I wasn't really fan of some electronical gadgets, but since about a year I'm using a smartwatch. I won't be promoting a specific brand here, but it tracks my activity, and definitely while working in tech, we spent lots of time by our desks, and having a tool that tells you let's have a walk is definitely a game changer. And if you also monitor the water supply, this is also pretty cool. We should be caring not only about the code quality, but also about our life quality. And that I really encourage you to have a look and buy one if you do not have any. And I'm not a gadget guy at all. I used to be using an old Nokia phone, even like 4 or 5 years ago. So definitely not really into novelties, not the technical ones. But this is really a really cool one. So this is actually the tool. If my mobile phone is running out of the battery, I'm not really caring much about that. But if I just lose the cable powering this stuff, I would be a bit worried. So definitely something that changes your life. Right now, I'm taking like 10,000 steps every single day, and that really improves the quality of my sleep and all this stuff. So I won't be talking much about and improving my code quality. Let's care about life quality first.
Yeah. Wow, that's cool. The last question for you. What's your favorite source to find out what's new and happening in tech?
Well, I was using Reddit for some time, but it's just quite complicated to follow all the subreddits that you might be interested in. And recently, I started using Hacker News more often. I just believe it's really cool to be up to date with the latest trends, because people are just putting the most relevant pieces here. They got upvoted. And I'm just trying to have a look at Hacker News website several times every single day. So I hope that keeps me up to date with the novelties.
All right, really cool. Okay, so with that, we come to the end of another fantastic episode here at the Amazing Podcast. So thank you so much for joining us and listening to us, everyone who's here now. And if you'd like what you listen to, you'd like to know more, go to amazic.com. That is amazic.com. Check out all of the other interviews we have. We also have articles, job listings, event coverage, like KubeCon and all of those. So go and check those out. And definitely also check out Qdrant from what we spoke about today. It sounds like a really cool tool that you should go and see what you can do with. And with that, I'd like to wrap up this interview. Thanks again, Kacper, for sharing your views and detailed responses for all of the questions. It was very insightful. Thank you so much.
Thank you. Thank you for the invitation. That was real pleasure to be here.
Thank you, viewers. Until the next interview, see you.